Alright, let's look at the homework 6.4, problem number 5. Alright, let's evaluate this given improper integral. Alright, so since it's going from negative infinity to positive infinity, I'm going to actually split this into two improper integrals. Alright, so let's say first one goes from negative infinity to, say, 0. X to the fourth, e to the negative x to the fifth with respect to x. And the second one goes from 0 all the way to positive infinity. And the rest is exactly the same. Alright, let's call this first integral I1. So I'm going to call this one I1, and I'm going to call the second one I2. Alright, so I1, let's compute I1. Alright, I'm going to use a substitution on this one. I'm going to let u be the exponent here. So this is going to be our u. Alright, so it's negative x to the fifth. Alright, going through the usual drills, we take the derivative of u with respect to x. So that's going to give us negative 5x to the fourth power. Alright, and then we're going to take the reciprocal of both sides so that we have a dx on top. So put everyone upside down. Dx over du is equal to 1 over negative 5x to the fourth power. Alright, then last step is we want to isolate dx, so we multiply through by du. So now dx is isolated, which is equivalent to du over negative 5x to the fourth power. Alright, so let's rewrite this integral. Actually, before we do that, I have to convert. So it's x is going from negative infinity to 0. So we convert this to a corresponding u value. Right? So if you plug in negative infinity here, so negative infinity, the fifth is still negative infinity, but there's a negative sign in front that makes it positive infinity. So you have a positive infinity to, right, if you plug in 0, it's 0 anyway, so we have that. Alright, so we have an integral from infinity to 0. Alright, seems like it's going backward, but that's okay. Alright, then you have x to the fourth. I'm going to leave it as it is. And then you have e to the exponent is now u. Alright, then dx is equivalent to du over negative 5x to the fourth. So du over negative 5x to the fourth power. Right? So we can cancel x to the fourth on top and the x to the fourth on the bottom. And also there's a constant, the negative 1/5 is just a constant, so we can pull it outside. Alright, so let's do that. So it's going to be negative 1 over 5. Alright, then so the troublemaker is here. Actually, before we do that, maybe I'll do this. Alright, so you have an integral from infinity to 0. Then what's left is only e to the u du. Alright, so one more thing I'm going to do is here, I'm going to incorporate this negative sign to switch 0 and infinity. So I put 0 on the bottom and infinity on top, and then we can just get rid of this negative sign. Alright, so then we know that here we have 1 over 5 is just a constant. All right, and the troublemaker in this case is having an infinity, so I'm going to replace by b, but we take the limit as b approaches infinity, right? And the lower limit is 0, and you have a e to the u du. All right, so this is a rather simple integration. So you have a 1 over 5, and we still take care of the limit later. Alright, so antiderivative of e to the u is e to the u again. You're going from 0 to b. Alright, so this is going to be equal to 1 over 5th is still there. You have a limit as b approaches infinity. And then we plug in b. So you have a e to the b minus e to the 0 is 1. Alright, then you can see that here, as b approaches infinity, e to the b approaches infinity. Infinity minus infinity is still infinity. So this is going to end up becoming infinity times 1 over 5th is still going to be infinity. So it means that this is going to be divergent. All right. So since there's another, we have I2 as well, but there's no point of evaluating I2 because I1 already diverges, which means that the original improper integral also diverges. All right. So here, answer would be diverges and diverges. All right. Let's check the answer. All right, it came back and looks like we got this one correctly. All right, that's it. I hope that this was clear.